Bloom syndrome, also known as vampire syndrome, is a genetic mutation that results in short height, skin rashes that occur after having been exposed to the sun, and an abnormally large risk of cancer. A person with this disorder will usually be smaller than 97% of the population in height and weight from birth. This is a very rare disease that affects a few hundred individuals. Usually, it affects Central and Eastern European people of Jewish descent. It is very uncommon for a person with Bloom syndrome to grow over 5 feet tall in their adult life. Cancer is a very common disease that infected individuals get. They usually get it very early in their life, effectively decreasing their lifespan. They will often get multiple types of cancer. People with Bloom syndrome have a low life expectancy of 27 years. To put that into perspective, a normal person's life expectancy is 71 years, which is more than double the life expectancy of a person with Bloom syndrome. Most of the deaths of people with Bloom syndrome are caused by cancer. This disease makes skin very sensitive to ultraviolet light or sun exposure. Butterfly-shaped patches of skin that are red and will appear and develop across the nose and cheek. Keep in mind that rashes can appear anywhere as long as they are exposed to sunlight. Blood vessels can and often do appear in rashes too. This is called telangiectasias. Telangiectasias can also occur in the eyes if exposed to sunlight. Patches that are dark or light also appear and cover the skin. Darkened patches of skin are called hyperpigmentation, and lightened patches of skin are called hypopigmentation. These kinds of patches will appear on parts of the skin that are not exposed to any sunlight. Bloom syndrome gives an individual an increased risk of diabetes. Symptoms of Bloom syndrome include high-pitched voice, facial features that are distinctive, telangiectatic erythema, pigmentation of sun-exposed areas, colitis, swelling of the lip, photosensitivity, improvement of disease with age, lack of subcutaneous fat, long narrow face, prominent nose, bird-like appearance, large ears, long limbs and arms proportionate to the body, disproportionately large hands and feet, increased harm from ear infections, respiratory and gastrointestinal infections, decreased A and M antibodies, increased harm from cancer, no sperm being able to be produced by men, sterile, reduced fertility and shortened reproductive span in women. Bloom syndrome is caused by mutations in the BLM gene. The BLM gene provides the blueprint or instructions for making one of the members of a protein family called REC helicases. Helicases are enzymes that bind to DNA and cut the DNA in half into two strands of DNA. REC helicases help keep the structure and integrity of DNA. They are known as the caretakers for the genome. When a cell is ready to divide, the DNA is copied so that each newly created cell will have two copies of each chromosome, one that is from each parent. The new copied DNA from each chromosome are arranged into two identical structures. These structures are called sister chromatids. They are attached to one another during the early phases of cell division and occasionally exchange small bits of DNA during this time. This process is known as sister chromatid exchange. Researchers suggest that the sister chromatid exchanges are responsible for the damage of the DNA during the copying process. BLM protein help with preventing too many sister chromatid exchange and also helps with other processes that help to keep the DNA stable during the copying processes. The problem with Bloom syndrome is that the individuals with it have mutations of the BLM gene. The mutations make BLM proteins non-functional. Now there is nothing preventing the sister chromatid exchange from going on. As a result, the exchange happens 10 times faster than it should compared to a normal person. Not only that, but because of the mutations in the BLM gene, chromosome breakage frequently happens to the chromosomes of these individuals. Things in the chromosomes start to get disarranged, resulting in breaking and gaps in the genetic code. Chromosome breakage greatly disrupts normal cell activities and causes health problems. What is even worse is that if DNA is damaged due to ultraviolet light, without the BLM proteins, damaged DNA is unable to be repaired. Even if the cell does manage to repair the DNA will never have a full recovery. Damages due to ultraviolet light result in increased sun sensitivity for individuals with this disorder. The ultraviolet light of the sun permanently changes genetic code. These genetic changes make cells divide in a rapid and uncontrolled way. This leads to cancers that eventually kill the people with Bloom syndrome. Bloom syndrome is a recessive gene mutation. It commonly affects the skin and bone. It is non-sex linked, and you cannot catch Bloom syndrome. To get Bloom syndrome, you have to have both copies of the mutated BLM gene in every cell to have mutations. If you just carry one copy of the mutations, you usually won't show any symptoms of the disease. Bloom syndrome is located on chromosome 15. This is also the place where the mutations of the BLM gene take place. Bloom syndrome has no real cure, but it is treated just like cancer, diabetes, and is also treated with antibiotics to decrease the frequency of sister chromatid exchanges. The cancer treatment is not recommended and should be avoided by individuals with Bloom syndrome because these individuals' cells have hypersensitivity to radiation, destroying their DNA and genetic code even more. Throughout my research, I've learned that Bloom syndrome is a disease, disorder, whatever you want to call it, that you don't want. That is all.
Hey, sugar. Come on over here, sweetie. Let's break it down. Glycolysis is a series of reactions, enzymatic actions, energy transactions. Takes glucose, a molecule so sugary, breaks it down to NADH and ATP. It's an anaerobic cytoplasmic pathway that amazes. Organized easily into 3 phases: investment, cleavage, and energy harvest. Tell me later which one you like best. Investment, activation, energy supplied. Cleavage, our 6 carbon sugar divides. Harvest, we get our energy yield. So beautiful, so intricate, keep your eyes peeled. Glycolysis, come on sugar for the breakdown, for the breakdown. Investments, like striking a match, that energy you put in makes the fire catch. For glycolysis investments, 2 ATPs, which act as activation energy.